Dear 10th standard students, in chapter Numbers and Sequence, the topic is series. In topic series, the subtopic is arithmetic progression. In arithmetic progression, I am going to teach sums from the exercise and the examples. Doing sums from the exercise 2.6, sum number 8 to 12 and examples 2.372, 2.39. Exercise 2.68 sum. Raghu wished to buy a laptop. He can buy it by paying rupees 40,000 cash or by giving it in 10 installment as rupees 4,800 in the first month and rupees 4,750 in the second month and rupees 4,700 in the third month and so on. If he pay the money in this fashion, find total amount paid in 10 installments. How much extra amount that he has to pay than the cost? Two choices are given to him. One is directly pay the amount 40,000. Second one is paying amount 10 installment. In the first installment he paid 4,800. Second installment 4,750. In the third installment 4,700 and then go on. To find total amount paid in the 10th installment and also find how much extra amount he paid than the cost. Cost of laptop is rupees 40,000. Installment in first month is rupees 4,800. Installment in the second month rupees 4,750. Installment in third month rupees 4,700. That is 4,800, 4,750, 4,700 form an AP. Here A is 4,800, D is 4,750 minus 4,800, we get minus 50, D is minus 50 and again is number of installment is 10. That total amount paid in 10 installment. Here Sn is n by 2, 2a plus n minus 1 into D. S10 is 10 by 2, 2 into 4,800 plus 10 minus 1 into minus 50. 2 into 4,800 9,600, 10 minus 1, 9 into minus 50, 5 into 9,600 plus 9 into minus 50, 9 into minus 50 minus 450, 9,600 minus 4,450, we get 9,150, 5 into 9,150, we get 45,750. Amount he paid extra in installment. 45,750 minus 40,000 is original cost, he paid amount. We get rupees 5,750. 9 sum. A man repays a loan of rupees 65,000 by paying rupees 400 in the first month and then increasing to payment by rupees 300 every month. How long will it take for him to clear the loan? Here, a man buy a loan rupees 65,000. He paying the amount by installment. In the first month, he paid 400. In the second month, increasing 300 rupees. Every month he is increasing 300 rupees. So A is here 400, D is 300. Loan amount is rupees 65,000. Amount of repayment in successive month 400 plus 700 plus 10,000 plus and so on n month is equal to rupees 65,000. Here A is 400, D is 700 minus 400, we get 300. N is to find. Sn is 65,000. Sn is 65,000. Sn formula is n by 2, 2a plus n minus 1 into D is equal to Sn. N by 2,
2 into A is 400 plus n minus 1 into D is 300 is equal to Sn is 65,000.
n by 2, 800 plus 300 n minus 300 is equal to 65,000. n by 2, 800 minus 300, 500 plus 300 n is equal to 65,000. n 500 divided by 2, 250 plus 300 divided by 2, we get 150 n is equal to 65,000. n into 250 plus 150 n is equal to 65,000. n into 150 n, 150 n square, n into 250, 250 n is equal to 65,000. 150 n square plus 250 n minus 65,000 is equal to 0. Divided by 50. 3n square plus 5n minus 1300 is equal to 0. Factorizing this, we get 3n plus 65 into n minus 20 is equal to 0. 3n plus 65 is equal to 0. n minus 20 is equal to 0. 3n is equal to minus 65. n is minus 65 with 3. n is 20. n is minus 6 by 3, not possible. Therefore, the number of months you take to clear the loan is 20. Exercise 2.6 10 sum. A brick staircase has a total of 30 steps. The bottom step requires 100 bricks. Each successive step requires 2 bricks less than the previous steps. How many bricks are required for the topmost step? How many bricks are required to build the staircase? Number of bricks in the bottom step 100, that is first step. Number of bricks in successive steps are decreased by 2, 98, 96, 94 and so on. Therefore, 100, 98, 96, 94 for 30 steps form an AP. Here, A is 100, D is 98 minus 100 minus 2, N is 30. Number of bricks used in the topmost step. The topmost step is 30th step. Tn is equal to A plus n minus 1 into D. T30 is equal to 100 plus 30 minus 1 into minus 2. 100 plus 29 into minus 2. 100 plus 29 into minus 2. 100 minus 48. 100 minus 58. T30 is 42. The topmost step required 42 bricks. Total number of bricks used to build a staircase. Sn is equal to n by 2 A plus L. Here A is 100, L is 42, n is 30. S30 is 30 by 2 into 100 plus 42. 30 by 2, 15 into 142. 15 into 142, 2130 bricks required to build the staircase. 11th sum. If S1, S2, S3 and up to Sm are the sums of n terms of m APs whose first term are 1, 2, 3 up to m and whose common difference is 1, 3, 5 up to 2m minus 1 respectively, then show that S1 plus S2 plus S3 plus and so on plus Sm is equal to 1 by 2 mn plus into mn plus 1. Let S1, S2, S3, Sm are the sum of n terms of an AP. The first terms are n, 2, 3 up to m respectively. Its common difference are 1, 3, 5 up to 2m minus 1 respectively. S1 is an AP. A is 1, D is 1. A is 1 and D is 1. S1 is n by 2, 2 into 1 plus n minus 1 into 1. S1 is n by 2, 2 plus n minus 1. S1 is n by 2, n plus 1. S2 is an AP. A is 2, D is 3. S2 is n by 2, 3n plus 1. Sm is an AP. A is m, D is 2m minus 1. N by 2, 2m plus n minus 1 into 2m minus 1. N by 2, 2m plus
2m into n, 2mn minus 2m into 1 minus 2m minus 1 into n minus n minus 1 into minus 1 plus 1 n by 2, 2m cancel, 2mn minus n plus 1. So Sm is n by 2, 2m minus 1 into n plus 1. To prove S1 plus S2 plus S3 plus so on plus Sm is equal to 1 by 2 mn into mn plus 1. Taking left hand side, S1 plus S2 plus S3 plus and so on plus Sm. Here S1 is n by 2 n plus 1 plus S2 is n by 2 3n plus 1 plus S3 is n by 2 5n plus 1 plus and so on plus Sm is n by 2 2m minus 1 into n plus 1 n by 2. Here taking out n plus 3n plus n plus 3n plus 5n plus so on plus 2m minus 1 into n plus 1 plus 1 plus 1 plus up to m times n by 2. Here n is common, taken out 1 plus 3 plus 5 plus so on plus 2m minus 1 1 plus 1 plus 1 we get m n by 2 n into 1 plus 3 plus 5 is odd number series. So the formula for odd number m square. So I write m square plus m n by 2 m square n plus m. Here m is common, we taken out mn by 2 into mn plus 1 we get right hand side. So hence proved. 12th sum, find the sum a minus d by a plus d plus 3a minus 2b by a plus b plus 5a minus 3b by a plus b plus up to 12 times. A is a minus b by a plus b, d is 3a minus 2b by a plus b minus a minus b by a plus b. LCM is a plus b, 3a minus a minus 2b plus b by a plus b, 3a minus a 2a 3a minus a 2a minus 2b plus b minus b by a plus b. D is 2a minus b by a plus b. Sn is n by 2 2a plus n minus 1 into d. Here S12 is equal to 12 by 2 into 2 into a minus b by a plus b plus 12 minus 1 into 2a minus b by a plus b. 12 by 2 6. A plus b is common, we taken out a plus b. 2 into a minus b plus 11 into 2a minus b. 6 by a plus b 2a minus 2b plus 22a minus 11b. 6 by a plus b 2a plus 22a 24a minus 2b minus 11b we get minus 13b. Example number 2.37. A mosaic is designed in the shape of an equilateral triangle 12 feet on each side. Each tile in the mosaic is in the shape of an equilateral triangle of 12 inch side. The tiles are alternate in color as shown in the figure. Find the number of tiles of each color and total number of tiles in the mosaic. Since the mosaic is in the shape of an equilateral triangle of 12 feet and the tile in the shape of an equilateral triangle of 12 inches 1 feet, there will be 12 rows in the mosaic. It is clear that number of white tiles in each row are 1, 2, 3, 4 up to 12, which clearly form an AP. Similarly, number of blue tiles in each row are 0, 1, 2, 3 up to 11, which is also an AP. Number of white tiles 1 plus 2 plus 3 plus and so on plus 12. Here A is 1, D is 1, N is 12 and L also 12. Last term is 12, number of term is 12. Sn is n by 2, A plus L. S12 is 12 by 2, 1 plus 12. 12 by 2, 6 into 1 plus 12, 13. 6 into 13, 78. Number of blue tiles 0 plus 1 plus 2 plus and so on plus 11. Here A is 0, D is 1 and N is 12, L is 11. Here last term is 11, number of term is 12. S12 is 12 by 2, 0 plus 11. 12 by 2, 6, 6 into 11, 6 into 11, 66. The total number of tiles in the mosaic 78 plus 66 is equal to 144 tiles. Example number 2.38. The houses of a street are numbered from 1 to 49. Senthil's house is numbered such that the sum of the numbers of the houses prior to Senthil's house is equal to the sum of the numbers of houses following Senthil's house. Find Senthil's house number. Let Senthil's house number be X. Total number of houses in the street is 49. Sum of the numbers of the houses prior to Senthil's house, that is equal to sum of the numbers of the houses following Senthil's house. Senthil's house is S. Prior to Senthil's house, starting from 1 to x minus 1. Following to Senthil's house, x plus 1 to 49. 1 plus 2 plus 3 plus and so on plus x minus 1 is equal to x plus 1 plus x plus 2 plus and so on plus 49. 1 plus 2 plus 3 plus and so on plus x minus 1 is equal to total number of house 49 starting from 1 to 49, that is minus from starting house to Senthil's house, that is 1 plus 2 plus 3 plus up to plus x. Here the left hand side, here a is 1, n is x minus 1, l also x minus 1. Total number of houses is x minus 1, last number is x minus 1. And in the right hand side, first here a is 1, n is 49, l also 49. Total number of is 49. The second set, a is 1, n is x, last is x. Total number of houses is x and l is x. Using formula, Sn is equal to n by 2 a plus l. X minus 1 by 2 into 1 plus x minus 1 is equal to 49 by 2 into 1 plus 49. X by 2 into 1 plus x. X minus 1 by 2. 1 minus 1, 0. X is equal to 49 by 2 into 1 plus 49, 50 minus x by 2 into x plus 1. X into x, x square, x into minus x, minus 1 minus x by 2 is equal to 49 into 50 by 2 minus x into x plus 1 by 2. Denominator having the same number 2, cancel that. X square minus x is equal to 49 into 50, 2450 minus x into x, x square minus x into 1 minus 1 minus x. Minus x minus x cancel. X square plus x square is equal to 2450. 2x square is equal to 2450. X square is equal to 1225. X is equal to 35. Square root of 1225 is 35. Therefore, Senthil's house number is 35. Example number 2.39. The sum of first n, 2n and 3n terms of an AP are S1, S2 and S3 respectively. Prove that S3 is equal to 3 into S2 minus S1. If S1, S2, S3 are the sum of the first n, 2n and 3n terms of an AP respectively, S1 is number of terms n. So n by 2 into 2a plus n minus 1 into d. S2 is number of terms 2n. 2n by 2 into 2a plus 2n minus 1 into d. S3 number of terms 3n. 3n by 2 into 2a plus 3n minus 1 into d. S2 minus 1 in the right hand side, S2 minus S1. So you take in the S2 minus S1. 2n by 2, 2a plus 2n minus 1 into d plus minus n by 2, 2a plus n minus 1 into d. N by 2 is common, we take it out, n by 2. 2 into 2a, 4a plus 2 into 2n minus 1 into d minus 2a plus n minus 1 into d. N by 2, 4a plus 2 into 2n, 4n, 2 into d into 2n, 4nd minus 2 into d minus 1 minus 2d minus 2a minus n into d, nd plus 1 into d, d. N by 2, 4a minus 2a, 2a plus 4nd minus nd, 3nd minus minus 2d plus d, d. n by 2, 2a. Here d is common, taken out. 3n minus 1 into d. 3 times of s2 minus s1 is 3 into n by 2, 2a plus 3n minus 1 into d. 3n by 2 into 2a plus 3n minus 1 into d is s3. 3 into s2 minus s1 is equal to s3, hence proved.